this video we'll be solving the question all elements in a two binary search tree. Now we must know that the in-order traversal of a binary search tree will give us all the elements in the sorted order. So what we'll do is we'll write a helper function that will do an in-order traversal on both the trees, that is root 1 and root 2, and we will store the output in a array list, and then we can use the merge process of the merge sort. So now if we do the in-order traversal of this tree, that is 1, 2 and 4, we'll get 1, then we'll get 2, and then we'll get 4. And now if we do the in-order traversal of this tree, then we'll get 0, we'll get 1, and then we'll get 3. Now as we see, we have basically two sorted lists, and now we need to merge them. And we can easily use the merge process of the merge sort. And then let's start writing the code and see, and then later on we will look at what the time complexity is. So first I will have a integer array list. I will call this list 1, and I will do the same since I need two array lists and then I need to merge them, and I'll call this list 2. Once this is done, I will have a helper method in which I will pass the root node and these lists as parameters. So I will pass this and list 1. I'll do the same for the second tree. So let's go ahead and write our method. Now since I really believe in writing good coding practices, it's always better to have a private methods. Ideally you would not want someone to access them, and this will take in tree node, root, and a list. Now I'll be writing the recursive approach of in-order traversal, but you could also go ahead and doing the iterative approach. Now it's always important to do the null checks. If the root is null, we need to return it. And now we know the in-order traversal is first we will be calling root left subtree of the root, and we'll be passing this array list. Now in this array list we will be adding root.val, and now we'll call the right subtree. We are done with the helper function. Now it's let's go ahead and write the merge process. Now we can ideally merge lists. I will pass list 1 to this and list 2 to this. I will again make my method as private, and this will actually be returning a list of integers, merge list, and this will be taking two sorted integer lists. I'll call them list 1 and list 2. Now it's let's first go ahead and have a output or a answer list that is going to be returned from this method. And now since we know both the lists are sorted, we can do somewhat like have two variables that will be keeping track of the indexes. We will initialize them to 0, and then using a loop we will be iterating these two arrays. We need to have a condition while I is less than list 1 dot size, and at the same time j is also less than list 2 dot size. Now inside this while loop we need to decide whether we need to insert an element from list 1 or insert an element from list 2. So we will compare elements at both the indexes respectively and then insert. So if list 1 dot get I is greater than list 2 dot get j, then we need to insert an element from list 2. So we will do answer dot add list 2 dot get j plus plus, because after inserting the element in this answer list we also need to update the index as well. Else answer dot add list 2 dot I plus plus. Now once we are done iterating both the lists, there can be a possibility that the number of elements in list 1 and list 2 are not same. So we also need to check if there are no elements left in any of those lists. So outside this while loop we'll also have to traverse both these lists once. Answer dot add list 1 dot get I, and similarly we have to traverse the second list. Answer dot add list 2 dot get j plus plus. 1 second, we missed out doing updating the index, and then finally we can return this answer list. And let's go ahead and run our code once. Cannot be applied to given type. Oh, we all, I missed sending this. So solution is accepted. So we can see it is 81.26. Let's go ahead and look at the time complexity of this. So in order traversal of a tree takes O of n. Let's say the first tree has n1 nodes and second tree has n2 nodes. So both the time complexity is going to be n1 plus n2. Since there is a method call to in order function is going to take n1 and n2 here, and then again we are traversing it this side by calling the merge function. We could have also done it using the collections dot sort method that's available in Java, but then the time complexity for this would have been n log n. So this is not good. That's why this is this is a better approach of solving this question. Thank you guys for watching my video. I'll be uploading videos regularly, and keep coding. Thanks.